This is an explanation of the CHUMP. The basic layout of it, we have our clock at the bottom, our program counter, program ROM, address register, selector, our multiplexer, RAM, accumulator, ALU, control ROM, and this is just the NOT chip used to invert the ROM. So from there we can go look at the basic function. So it's pretty simple. It takes a value, takes the pulse in to the program counter, and with each pulse it counts 1 in an internal counter, which is displayed through these 4 LEDs in binary from least significant to most significant bit. That value is then used to count through the addresses in the program ROM, where in each address is a line of code basically, so you can think of the program counter like the line number. And as it counts through, it outputs each line of code. 4 of the bits go to the control ROM. The opcode, you could say, goes to the control ROM, which breaks it down and sends it out to all the different parts of the ALU and these green control wires. The number goes to the selector, and then there you can see it will compete with another number, and depending on the select pin, either number will be forwarded through. So it'll either be that constant or it'll be a number from RAM, but whichever number goes through, it can either be used to switch the current line that is reading, so you can switch and go to another line and it'll start counting from there in the program counter, or it can be used as an address, or it can be sent into the B input of the ALU and used as a number for computation. So you can do whatever function you want depending on the control codes. Then it'll send that value and store it in the accumulator. The accumulator then either uses that to further do more complex calculations with more numbers, or it will send it and store it in RAM. If you're writing to RAM, it'll use the address presented here and the value here, and it will go to that address and store that value there. Or if you're set to read, then whatever address is being presented, it will read that and send it out, and that'll send it up to the selector that we talked about before. So that's kind of the basic functioning of it. If I put power in, and we can see the code here. It will be jumpy to start off with, but if I reset it to a reasonable value. So, as I said before, these 4 are showing the value that is the line number, essentially. So it'll be showing one of these numbers, and it'll count through. As you can see, it'll count up to 4, and then it'll go back to 0. So if we start at 0, and we can see these are our the outputs from our accumulator, and these are the outputs for our RAM. So you can see it's or the inputs for our RAM, sorry. It's pretty simple. Right here, their inputs are reversed, so it'll go whichever LED is high means that it's low, and whichever LED is low, which means that it's high, basically. It's just the inverse of what it actually is. So keep that in mind when you're looking at these LEDs. But these LEDs are the way they should be, and again, that's least significant bit to most significant bit, and least significant bit to most significant bit. So if I count through here, we can see that it'll count through each line of code, and with each iteration, it'll basically just take a value from address 2 in the in the RAM, put it in the accumulator, add 1 to it, store it back, and keep doing the same. So as you can see, we've gone to 3 now that we've run through this line of code. Now we're at 4 that we've run through it again. We go back to line 0, count through, add another one to it when we're at line 3, and then keep going, and it will keep adding up until we get all the way, and once we reach the maximum value, it will just reset and go back to 0. And as you can see, all of these are high now because all of these are low, and these will just sort of be the opposite of what's stored in the accumulator. And if we keep going, it'll count, and we've got a 1 again, and it'll count up through that. Or you can put it in the manual mode, or the automatic mode, where it will just count through itself. And here you can see the signals just naturally going up. And these are just the value being presented at the address. So sometimes it'll look wacky, and we aren't always using the value here, but you'll see that 2 will pop up quite often, and that's where we're fetching from and storing the value. So that is a brief explanation of the CHUMP.